Hello and welcome, everyone. If you're gearing up for your GCSE Computer Science J2077/02 paper, then you are in the perfect spot. Today, we're going to get you completely sorted on one of the most vital skills you need, mastering program testing.
Okay, let me paint you a picture. You've been coding for hours, you finally hit run and… Yes! No error messages, it works! But hang on a second, the output is totally wrong. Your program runs, sure, but it's not right. This is such a common thing, and it's exactly why we need a really smart way to test our code.
So, in this session, we're going to build your testing strategy from the ground up. We'll kick things off with the why and when of testing. Then we'll get into spotting the difference between syntax and logic errors, which is a huge deal. After that, we'll look at choosing the right kind of test data before we pull it all together into a perfect test plan that'll get you top marks.
All right, first things first, let's get right down to it. The why and when of testing.
So, why do we even need to test? Well, the whole point is to hunt down those pesky errors and make sure that your program is reliable and actually does what it's supposed to do. It's not just about fixing bugs, it's about being confident that your software actually works.
Now, when you test is just as important as why. You've got two main ways to go about it. On the left, you've got iterative testing. This is where you test little bits as you go, checking each part as you build it. Honestly, it's brilliant for catching problems early. On the right is final or terminal testing. That's when you wait right until the end and test the whole thing in one go. Both can work, but trust me, that iterative approach is going to save you a world of headaches later on.
Okay, so we know why we're testing, but what kind of errors are we even looking for? This brings us to a really key idea, knowing the difference between syntax and logic errors.
You absolutely need to know this for your exam. Syntax errors are basically like spelling or grammar mistakes in your code. You forgot a colon or you misspelled a keyword. Your computer will usually spot these for you and just refuse to run the program. But logic errors, these are much, much sneakier. The code's grammar is perfect, so the program runs just fine, but the actual thinking behind it is wrong. It's like a recipe that tells you to add a cup of salt when it should have been sugar. You followed all the steps perfectly, but the cake is disgusting. And guess what? The computer can't find these for you. You have to be the detective.
So, to find those tricky logic errors, you can't just poke at your program randomly and hope for the best. Nope. You need a smart, organized plan, and that all starts with choosing the right kind of test data. Let's start with the most obvious one, normal test data. This is just sensible, valid stuff that's right in the middle of what you'd expect. It's the happy path, data your program should be able to handle no problem.
And you can see exactly what that looks like here. If your program needs an age between 12 and 65, well, normal data would be something like 18 or 35. Simple, right? Or for an exam score from 0 to 100, you might try 50 or 89. Easy. But this is just the beginning of a proper test.
Okay, now this is where good testing really starts. Boundary test data. This is all about testing the values at the absolute edges of your conditions, because this is exactly where programs love to break. That classic greater than versus greater than or equal to mistake? Now look really closely at this table. For that age range of 12 to 65, we don't just test 12 and 65. The really clever thing to do is to also test 11 and 66, the values just outside the valid range. This is how you catch those super annoying off by 1 errors. Testing these boundaries is absolutely crucial. Next on our list is invalid test data. Now, this is data that's the right type, like it's a number when you're expecting a number, but it's way outside the acceptable range. A good, robust program should see this and just politely say, no thanks.
You can see it right here. For an age between 12 and 65, putting in something like -5 or 100 is clearly wrong. A badly written program might just accept it and give you some weird result. A good program will spot that the input is out of range and give a helpful error message.
And finally, we have the ultimate challenge for a robust program, erroneous test data. This is what happens when a user types in something that is the completely wrong data type. What if they type text when your program is waiting for a number?
This slide shows it perfectly. Your program is asking for an age, and it gets the word 12 or just a bunch of random letters. A fragile program will just crash and burn. But a robust program, the kind of program that gets you the best marks, will handle that error, reject the input, and ask the user to try again. That is what defensive design is all about.
So, you've figured out all this amazing test data. How do you actually present it in your exam to prove to the examiner that you've done a thorough, systematic job? Easy. You use a test plan.
This right here is the perfect structure. This is your proof. For every single test, you need an ID, the actual data you're typing in, and what type of test it is. But then come the two most important columns, what you expect to happen, and then what actually happens when you run it. The final column is just a simple verdict. Did it pass or fail? An examiner who sees this table knows you know your stuff.
Okay, let's wrap this up. The main takeaway here is that really getting these testing ideas is what separates someone who just messes around with code from someone who can build a truly robust program. This isn't just about passing your J277/02 paper. This is a fundamental, professional skill for anyone who wants to write great software. So, I'll leave you with a final thought to take with you. Based on everything we've just talked about, what's the one kind of bug, the one type of error that you are never, ever going to let slip past your testing again? Have a think about that. Good luck with the revision, and thanks for watching.